Okay, so what makes an ellipse is you have two foci.
What did you say?
And the distance to the first one plus the distance to the second one is always a constant, which means it's the same number. So we always do the foci, even though they aren't actually physically on the graph, they do make the graph. All right, Roman numeral 1, we're going to do vocabulary and labels. I am going to color code this. So if you have a couple colors of ink, that's going to help keep things clear from top and bottom. Roman numeral 2 is going to be standard vertex form, which is about 3 rows down. So standard vertex form. So on the top part in the vocabulary and labels section, draw yourself a big axis that fills the space. In the bottom part, we're actually going to do a chart. So put a line down the middle and then count about 1, 2, 3, 4, about 5 spaces down and make the cross piece. Column chart. Again, a ruler would be really helpful today. We're going to do a lot of line drawing. All right, so we're going to, the ellipses actually can lay on their long side or their pointy side. We're going to have one laying on its fat side just so that we have a clear picture. So 1, 2, 3, 4, 5. Okay, so my center is going to be H comma K. We're just going to put that at 0, 0. And then I want you to count 5 to the right. 1, 2, 3, 4, 5. Make a dot. 5 to the left. 1, 2, 3, 4, 5. 3 up and 3 down. Now, to draw an ellipse, you don't want it to turn out looking like a diamond or being pointy. So here's a trick to drawing them that works, and I am, because you know, completely not artistic. So if you put a small line through each of the 4 vertices and then connect them with a nice rounded curve, you're going to avoid the pointy issue that tends to come up. Okay, so when you're looking at an ellipse, there's obviously a longer axis and a shorter axis. The longer axis, and yes, I'm using red, is the major axis. The major axis is the longest axis of the two. And the way you find it is from the center. If it's a horizontal major axis, you count A spaces to the right and A spaces to the left. So that will give us vertex 1 and vertex 2. The length of the major axis from one vertex to the other is A plus A, which is 2A. So length equals 2A. So that is the longer of the 2 axes. Switching colors. Okay, the shorter of the 2 axes is called the minor axis. Again, the minor axis is the shortest one, in this case, vertical, going up and down. The distance from the center to the co-vertex, which is what you call the endpoints, is B. So you go up B and down B. And to distinguish vertices from co-vertices, the minor axis vertices are called co-vertices. So this is co-vertex 1. This is co-vertex 2. When you list them, you don't have to put 1 and 2, but you do need to distinguish between co-vertex and vertex. If it just says find the vertices, they're assuming you're going to find 2 vertices and 2 co-vertices. So the word vertices covers both. Big family. Okay, so We have vertices and co-vertices. We have a longer major axis and a shorter minor axis. Going to blue. All right, the points that create the ellipse are the foci. The foci are always on the major axis. They're never on the minor axis. Because of how the ellipse is made, the foci are always inside the vertices. Now, we don't usually put these on a graph because they aren't actually part of the ellipse. They're just the construct that makes the ellipse, but we're going to put them on our diagram just for today. So let's make a little dot just inside the vertex. We'll make this focus 1, and then the other one on the other side just inside the vertex. That's just focus 2. And the distance from the center to the focus is C, lowercase c, not to be confused with uppercase C for the center. Now, to find the foci from the ellipse equation, we have what I call a utility equation. It means it's not the main one, but it's used to find the pieces in parts. And it is a squared minus b squared equals c squared. And that is what you must use to find the C, which you will use to find the foci. So we have A's, we have B's, we have C's, we have H's, and we have K's. So Roman numeral 2, we're going to get into now the actual formulas for these graphs. There are 2 sets. And on the left, you can just quick sketch these. We're going to do the formulas for an ellipse laying on its long edge. We would say that that has a horizontal major axis. And then in our right column, we're going to do the formulas for an ellipse that's on its pointy end, so skinny. And that one is referred to as having a vertical major axis. All right, I'm using red just because they're formulas, not because it matches the drawing. So horizontal major axis, here's how the formula goes. X minus h quantity squared. And you go, hey, Ms. Wright, this is really close to circles. Yes, yes, it is. Except it's over a squared plus y minus k squared over b squared equals 1. That's a huge difference. Ellipses are always equal to 1. And in this formula, A is always greater than B, which means A is bigger. So if it has a horizontal major axis, the A squared will be under the X term, which tells you you need to count left and right. So the term it's under tells you which way to count the value. Now, for a vertical major axis, it's also X minus H squared, except it's over B squared. And then plus y minus k squared over a squared. It also equals 1. A is still bigger than B, it's just moved. So if you have a vertical major axis, the bigger number is under the y, and you're going to count A up and down from the center because it's a vertical major axis. Now, much of what we're going to do is just counting spaces on a graph, but there are formulas for vertices and co-vertices, and I'm going to give those to you so you have them. So for the vertices, back to the horizontal major axis, the vertices are h plus and minus a, comma k, and the co-vertices are h, comma k plus minus b. So for the vertices, you're going right and left. For the co-vertices, you're going up and down. Switch over to the vertical major axis. The vertices are h, comma k plus minus a, and the co-vertices are h plus minus b, comma k. So in this case, the bigger number is in the y position. You're going to count the bigger number up and down, the smaller number left and right. And again, the one formula that is the same is a squared minus b squared equals c squared, which is the relationship between a, b, and the foci. This is good for both. It never changes. However, how you use the C will change because the foci are always on the major axis. So for the horizontal major axis, the foci are going to be H plus minus C comma K, so left and right on the major axis. And for the vertical major axis, it's going to be H comma K plus minus C. You're going to go up and down to locate the foci. So where you count depends on where the major axis is. All right, flip the page. We're going to practice. So Roman numeral 3, we're going to practice doing a graph, and then we're going to practice doing the algebra. Okay, so this is practice. And our example is x minus 7 squared over 36 plus y minus 3 squared over 25 equals 1. Okay, and because of where the center is, put your y-axis just like one space off the edge. Draw it nearly down to the top of the hole punch in your paper, and then count up 1, 2, 3, like 4 spaces, and put your cross piece in. And it can go a little bit past the middle. You won't need much more space than that. And because I'm struggling with keeping things tidy today, I'm going to put a vertical bar in. You don't have to. It's just there to help me space my work out. All right. So we are going to graph this ellipse. So we're going to go through the steps. Number 1, first thing you should do is identify which is a squared. In other words, which of the bottom numbers is the bigger number. Now, in this case, 36 is bigger than 25. 36 is under the x, which means we have a horizontal major axis. Now, visually, this means that it's going to be laying on its longer side. So the bigger A tells you which way you're going to be counting, which is left and right. Okay, number 2. You need to find the center, just like you did for circles, which will be +7, +3. And let's plot that on the graph. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. And you might want to label your center up and to the right because of how we count. That will keep it out of your way. So we have our center. We know it's laying on its long edge. Now let's get into the 4 points of the compass. Number 3, we need to find A and B because that's how much we count. Now I am going to color code this with the front. So our major axis is under the X, and I have A squared equals 36. Let's take a square root of both sides. So A equals 6 on the major axis. So because we have a horizontal major axis, or you could think of it like the 36 is under the X, from the center, count 6 right. 1, 2, 3, 4, 5, 6, make a point, and from the center, go 6 left. And we will label those in a second. Okay, so the other number we need to look at is the B squared, which is the smaller one. That one equals 25. Square root both sides, you get B equals 5. So in my minor axis, from the center to the edge will be 5. So starting at your center, count up 5. 1, 2, 3, 4, 5. And count down 5. 1, 2, 3, 4, 5. Okay, remember that little trick I showed you? Put little lines through your 4 points to keep it from getting pointy. And then make your nice round ellipse by connecting those lines. All right, now we're ready to label. And again, you can memorize all the vertex labeling stuff or just count the spaces. I obviously count spaces a lot. So you go 7 to the right, and then A is 6. 7 plus 6 is 13, and then up 3. The left one, you can tell it's just 1 to the right, up 3. And then we're going to label this with a V for vertex. That way you don't have to write out the word vertex. All right, so now we're going to label the co-vertices. So we're going 7 to the right and up 5. So 3 plus 5 is 8. So my co-vertex up here is 7 to the right, up 8. So co/v, hyphen v will work. Down here, my co-vertex is 7 to the right and down 2. 7 and -2. That is all that needs to be on your graph, is the center and the 4 points of the compass indicating vertices and co-vertices, and that's it. That's the graph. But we always have to find the foci because they created the graph. So remember your equation for the foci is a squared minus b squared equals c squared. So we're going to fill in a squared and b squared and find c. So c squared equals 36 minus 25. Now, if you have nice, pretty whole numbers for vertices, typically your foci are weirdo numbers. If they're not, check your math. They're almost always strange numbers. So c squared equals 11, square root both sides, you get c equals radical 11. Okay, so to find the foci, you have to remember which axis it's on. The foci are on the major axis, which means from the center, you're going to be going right and left. Now, you don't have to put the foci on the graph, but this is notes. Square root 11 is like 3.9. So if I had to put these on the graph, it'd be like 1, 2, 3.9 here, 1, 2, 3.9 here. And this would be my focus 1 and my focus 2. The rounder the ellipse, the further in the foci go. The skinnier the ellipse, the farther into the corners they go. But I just need the coordinates. So with that as a visual, I know I'm going to go to the right 7, and then I need to add c. So 7 plus radical 11. And then from the center, it's not going up and down, so it's comma 3. Now to find the other one, I'm going to go to the right 7, and this time I'm going to go to the left radical 11, so minus radical 11, and again, up 3. So your foci, you can just box or square and put that over on the side with your other information. If you want to put it on the graph, you can, but that's not part of an ellipse. It makes it, it's not a part of it. All right, so let's go on. That is your basic graphing. So find the center, find A, find B, count the spaces, get the corners, calculate the foci. That's the overview. All right, let's hit the algebra. Example 2. So we have mystery equation, 16x squared plus 4y squared minus 24y minus 28 equals 0. In this form, it's really hard to tell if you have a circle, an ellipse, or a hyperbola. You know it's not a parabola because the x and the y are squared. So actually, all of those start the same way, which is you got to complete the square for x and complete the square for y. So let's do that. I have a 16x squared, but no more x's, so that one's done. Plus 4y squared minus 24y, leave a space. And then I'm going to add the 28 over to the right, leave a space. Now, unlike circles where the x and the y typically didn't have a coefficient, these will have coefficients. So out of my y's, I can divide a 4. So the 4 goes in front, and then in parentheses, I have y squared minus 6y, leave a space. So if you have a scalar, you must divide it off. Okay, now we're going to calculate our magic number. So our b is -6, so b divided by 2 quantity squared is -6 over 2 squared, or -3 squared, which is a positive 9. So we're going to add 9. Now here's where you got to be careful. I didn't just add a 9. I just added a 4 times a 9. So I really just added a 36. So to keep it balanced, I have to add 36 to the right side. So watch out for those scalars. Okay, let's complete the square. So I've got 16x squared plus 4 times y minus 3 squared equals 64. Okay, here is where circles, ellipses, and hyperbolas diverge. You know it's an ellipse because it has a plus here and a plus there. And you know it's not a circle because you have scalars all over the place. Okay, so what's the biggest difference between an ellipse formula and a circle formula? What's the biggest difference? Yeah, the ellipse is always equal to 1, right? And circles, there's lots of different radii. So that's what you're going to do. So at this stage, once you know it's an ellipse, you're basically going to force it equal to 1 because in an ellipse, it always equals 1. So to make that 64 into a 1, I'm going to divide by 64, which means I have to divide by 64 in all 3 places. Now, these equations are beautifully manipulated, so 99% of the time, you're going to get lovely whole numbers. 16 goes into 64 4 times plus y minus 3 squared. 4 goes into 64 16 times, and that equals 1. And you have your ellipse. Again, all but I think problem 1, everything goes in beautifully as whole numbers. If not, check your math. Now, of course, there's one weirdo question that they do like right at the beginning of your homework. So I'm going to show you how to deal with that. I don't want you to get discouraged right out of the gate. Let's say you've got something like 15x squared plus 3y squared equals 1. So it already equals 1, but you've got these scalars and you can't have the 15 and the 3 there. There are no scalars in the ellipse format. So only if it already equals a 1 and you have scalars. You only do that if it already equals 1 and you have scalars. So what I need to do is move the 15 and the 3. So put both of those over their 1s. I'm going to multiply the 15 by 1 over 15 on the top and 1 over 15 on the bottom. What happens is the 15s cancel on the top, and now I have x squared over 1/15. Weird, but correct. We're going to do the same thing with the 3. I'm going to multiply the top by 1/3 and the bottom by 1/3. The 3's cancel on the top, and I get y squared over 1/3 equaling 1. The very first equation on your homework, I don't know why they did it for the very first one. You have to do this to get it into the right form. They picked nicer numbers, though, than 15 and 3. All right, that is everything for the notes. Any questions?